Hey everyone, welcome to the first video of my practical troubleshooting series. In this series, we'll having a look at the different troubleshooting scenarios that we SREs face every day. So today, we are seeing a server that is having high latency serving the web request. So we'll be troubleshooting it further. Okay, let's get started. Let's start the server first. So let me just search into it. I have the code written already for the server and client. You can find the link to that in the video description. So let's start the server. Cool. So the server is running. Let's just switch into the same server and start a client. And we need to give an URL. So just localhost on port 5000. Okay. Now you can see that our client is making the request and it is seeing a latency of in some milliseconds. So that seems fine. Now let's say something happens with your server and suddenly your client started seeing high latencies. So let's do that as well. I have to do pretty much the same thing. Part 1, 3, client.py. Just the endpoint will be different this time. So localhost 5000 and then chaos. Let's cause some chaos. Okay, battery, ignore that. Okay, so now you can see the latency has increased from some milliseconds to actually 1.7, 1.6 second, 1.9. It will even reach up to 2, I think. So in that particular situation, your clients will reach out to you that we are seeing high latency from your web server and you have to troubleshoot that. This is a very common scenario that we SREs face every day. So yep, let's see how will you troubleshoot here. So very first step, just SSH into the server and see what is happening. First of all, you would like to get a very quick overview on the server, like what is really happening. So just do uptime. Okay, so the thing to note here is you want to check the load averages. So load average is nothing but the average number of process that are in running or uninterruptible state. So these three values are that same thing in like average of 1 minute, average of 5 minutes and average of 15 minutes. Now, as you can see the average of 1 minute, I am seeing a value of 1.26. Now, how to decide if this is a good or a bad value? So this value should be smaller than the number of cores your CPU have. If it is more than that, that means there are more processes in your queue than the number of cores you have. So your CPU, you are short on CPUs. Your CPU is struggling a bit to run all those processes, right? They're accumulating in the queue because CPU doesn't have enough bandwidth to run them all right away. Cool. So how to check the number of cores you have? Just put a proc and then CPU info. You will find the number of cores here. So it says the number of, I have only one core and it is 1.26. Let's check again what is happening with uptime. Now the load averages are up to 2.16. So yeah, CPU is definitely busy. It is doing something. Now we want to get more detailed view. So let's do top. Okay. So on the very first line, you can see there are load averages. There is time since the server is up. It doesn't matter. Then have a look at the CPU row and note some values over here. So the very first is the amount of time your CPU is spending running the process that are in user space. This is US 10 from user space. So it is 4.4. Nothing that much, right? This SY is basically the amount of time your CPU is spending in running the process that are in kernel space. 2.0 again, not that much. NI, it is a number of it is the average number of it is average time that a CPU is spending in manually resetting the nice values. 0.0, nothing that much. ID is basically the idle thing. When a CPU is doing nothing, that will contribute to idle. It is doing something, idle is 0. Definitely something is happening. WA, okay. WA is the amount of time your CPU is spending waiting on IO. So you can see this one is trending. This is around 90%. So that gives an idea that something might be wrong with the disk. Either the disk is failing or it is getting more requests than it can handle. But definitely something is wrong with disk. Okay. If you have a look at these like top trending processes, MySQL Daemon, 4.3%, nothing that much, right? 4.3% of CPU, not that much. 3%, Python 3 is taking 3%, that is fine. So till now we have an idea that something might be wrong with the disk, or the disk is getting more requests than it can handle. Let's check if something is wrong with the disk, maybe a case of bad hardware or something. For that, you can check D messages. -T is for human readable timestamp. I should have done the sudo. Okay, you can see there is nothing out of ordinary over here. Nothing like hardware failure or something. I cannot spot anything like that over here. So seems like there is it is not an hardware failure or something. Okay, so which means that there must be some process that is making too much request to the disk, right? Now we need more disk level data. For that we can use iostat. So sudo iostat st, just a second. Okay, so for these parameters you can read the main page of iostat and see what these are exactly for. So looking at the utilizations over here, you can see that for SDA, for this guy, we have utilization of around 98.48%, 98.32%. So which means something is causing too much load towards SDA. Too many disk operations are happening. But again, the question is which process is it and why is it happening, right? So next command that you can check is iotop. Iotop will give you a fair idea about which process is basically using IO. Top is for CPU, top is, you can see it shows CPU level statistics. iotop, just the same thing for IO, right? So one thing you will note here is JDB2 SDA 1 to 8 is doing something, and it's taking 90%, 92% of the disk utilization. So something is happening. But what is this JDB2? We don't have any idea, right? If you do a quick Google search on this, or just do some research, you'll find something. And then what is this? This JDB stands for general block device. Now what happens in a journaling file system is, by the way, ext3 and ext4 are journaling file systems, to name a few, and we are running ext4 on the server, right? So what is happening right now, when a write comes, that write goes to the journal area first and then to the file system. Now why we are doing this? Because writing to the disk or reading from the disk is not an atomic operation, right? They happens in step. There are many steps involved in that, and if the system crashes in between of any of those steps, that might leave your file system in an inconsistent state. And to avoid that, these journaling file systems are for. Now what do I mean by that? Let's say there comes a write. We'll first write about that operation, the metadata, and the data to the journal area in an atomic operation, right? And once we've done that, we'll make the write to the actual file system. And if the file system write or read is successful, then we'll delete that entry from the journal area. Now why we're doing that? Because let's say there happens a failure during the time when you're writing to the disk. In that case, when a system comes online the next time, it will have a look at the journal area. It will check, okay, this particular entry is remaining in the journal area. That means that I still have to complete this operation. So it will pick up that entry, complete the operation, remove that one from the journal area, right? So in that case, you will not lose your data, even if a system crash happens between while the time this operation is happening. So what is happening here is, there might be some process that is making disk operations, and those disk operations are first going to the JDB, that is journal block device, then they are going to the journal area. So that's the reason we are seeing high JDB usage, because JDB is doing all that work of writing those operations to the journal area. That's the reason we are saying 87.92% utilization. This will not give you an idea about which process is that is making request to JDB. To do that, there is no straightforward way. You cannot do a backtrace from JDB to like about which process is making the request and all. But another thing to note here is this disk write, right? You'll have a look here that MySQL daemon is doing something, just making some disk writes, even and also my that Python 3 server.py file, right? So these are something that are making write to this. So I have a fair idea now that MySQL is doing something. It is writing something to the disk, right? So now next step we want to check what is happening exactly. And to that, if you have logging enabled in your MySQL deployment, and check the logs. So I have that enabled in temp. Yeah, I know, not a good place to store logs, but yeah, still. Let's do a cat on that. And make sure all this to the tail. You just want the latest one, not everything. Okay, so you can see we are making some inserts. We are writing something to the database, and there are many queries. Like, let's check the time once. Okay, it is 10:32 minutes and 37 seconds, and now you can see that we are making many writes to the database. So something is happening, and many commits as well, right? So this should be enough for your development team or for yourself to actually trace back in your application, like what is from where it is happening. It should be enough, right? If not, you can also check the application level logs if your application logging something to see what is happening. And in this particular case, let's check our server.py file and see what is exactly happening. Okay, so initially we called an root endpoint, so that there is nothing. It is calling a function that is get file content. Get file content is here, so we have a file. We check for that. If that exists, we remove that. We create a new file, this get file. We write some numbers into it and read those numbers and return back to our function, calling function, right? So it is taking some. It is using disk, right? This function is using disk IO. Okay, my bad. That happens when you code in both C++ and Java. Sorry, C++ and Python. So this happens. Okay, so this function is using some amount of disk IO. Using some disk IO. And if you have a look at the chaos function, that it is doing nothing. It is an infinite loop. It writes to the table and it deletes from it, and it does it continuously. So that explains what is happening right now. This function is causing too much disk utilization. So this function call is actually in the queue, waiting for its turn to do the IO, right? So that's what's happening. That's the main cause of latency. So if as soon as we stop this chaos, this loop, it should be fine. But there is no way, right? Once I have made the request, it is already in the infinite loop state. Even if though I exit the call, then even in that case nothing happens. And why nothing happens, I want you guys to let me know in the comment section. Cool. So this was a pretty small demonstration of how would you troubleshoot a server that is having high disk IO. If you like the video, smash the like button, subscribe to the channel, and I'll be back with another part of practical troubleshooting as early as I can. Thank you so much. I'll see you next time. Bye-bye.